Here is the next example. Here he's asking about find the z parameters. Okay, so it's a completely resistive or resistant circuit. So first thing we need to do in z parameters, always, it doesn't matter, in two-port network we always take I1 entering V1, I2, remember, always entering, this is V2. Okay, so this is a two-port network, so you need to make sure that V1, I1, and I1 is entering, I2 is entering, and V1 is positive on the top, V2 is also positive on the top. Now what are the equations for the impedance parameters? So you need to remember this: V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. Here V1 and V2 are dependent quantities and I1 and I2 are independent quantities. So to find Z11, it's V1 over I1 when I2 equal to 0, and same way Z12 equal to V1 over I2 when I1 equal to 0, and Z21 equal to V2 over I1 when I2 equal to 0, Z22 equal to V2 over I2 when I1 equal to 0. So Z impedance is nothing but V over I. So 1 indicates V1 over I1, 1 indicates, I mean, the first letter is the numerator, second letter is the denominator, and you can find that. So here Z11 is the input impedance, and Z12 is the open circuit transfer impedance from port 1 to port 2. Z21 open circuit transfer impedance from port 2 to port 1. Z22 is open circuit output impedance. All these are all open circuit impedances because we are saying I2 or I1, one of the current is 0, so current is going to be 0 when it is open circuit. Now, as I mentioned, we always use same circuit. I mean, here I2 equal to 0, I2 equal to 0. So to find Z11, Z21, we're going to use the same circuit. So I always recommend you to find these two parameters, Z11 and Z21, at the same, I mean, one after other. Instead of finding Z12, after finding Z11, I'm going to find Z21 in this case. So here is my circuit. Okay, it's the same circuit. Here is my I2. I'm saying this value is 0, but V2 is not 0. So V2 is the voltage drop across this 4 ohm resistor, 8 ohm resistor, 12 ohm, and 2 ohm. Here is my I1 and V1. Now to find Z11, all I need to do is V1 over I1. So I know V1 is nothing but I1 times whatever this total impedance, Z total. Okay, all I need to do is find that Z total. That Z total is nothing but Z11. So so this is look like a ladder circuit from looking at the input. So here is my input point of view. I'm looking from these two point of view. I mean, this port 1 point of view. When I'm looking at the port 1 point of view, this look like a ladder circuit. So always start from the resistance which is far away from the input terminal. So 8 and 4 are in series, which is going to be 12 ohms. 12 is parallel with 12. So my Z total equal to Z11 equal to, I'm going to write it down, 8 plus 4, that combination is parallel with 12, and the combination is parallel with, in series with 2. So 12 parallel with 12, which is 6 ohms. 12 times 12 divided by 12 plus 12. Shortcut is, I discussed many times in the class. So if you have two equal value resistors in parallel, it's going to be that resistance value divided by 2. If 3 equal value resistors are in parallel, that resistance value divided by 3. If 100 100 equal value resistors are in parallel, then that resistance value divided by 100. Okay, so the Z total or Z11 equal to 8 ohms in this case. Now we're going to find Z21. So the next quantity I'm going to find Z21. Z21 is nothing but V2 over I1. So I know here is my V2. Now I need to find I1. So I need to find the current passing through this branch in terms of I1. So whatever this current in terms of I1. Now can I say I1 is going to come over here and it's going to split. Okay, say let me take this as Ix and this as Iy. Okay, so V2 is nothing but 4 times Iy divided by I1. But now I need to find Iy in terms of I1. So if you look at here, I1 is going to come over there. So let me redraw this diagram. So if I redraw the diagram, I have 12 ohms, 8 and 4, they are also in series, so it's going to be parallel, the 12 ohms. So here is 12 ohms, here is 12 ohms. So what happens, whatever current comes here, I1, it's going to split equally. But here in this case it's going to split equally because we have equal value resistors. But if they're not equal, anyway you can find by using current division rule. Iy equal to total current I1 times opposite resistance over total resistance. So you will end up with I1 over 2. So what is Z21? Z21 equal to 4 times I1 over 2 divided by I1. So it's going to be 2 ohms. Here is my Z21. So as I mentioned, Z11 and Z21, it's easy to find together. Now we're going to find other two parameters. So to find other two parameters, I'm going to redraw the circuit diagram. So here is the circuit. I'm going to use two different colors. So here is my circuit: 2 ohm, 12 ohm, 8 ohm, 4 ohm. Okay, now I'm going to take I1 equal to 0. So if I1 equal to 0, can we ignore this 2 ohm resistor? Because there is no current passing through this, we can ignore this 2 ohm resistor. So whatever V1 is going to be right here, since there is no voltage drop across 2 ohm resistor. So V1 is voltage drop across this 12 ohm resistor, 8 ohm and 4 ohm. Okay, here is my V2 and I2. It's easy for me to find Z22 first. Z22 is nothing but V2 over I2. So now I'm looking at the circuit from the V2 point of view, from this port 2 point of view. Okay, if you look at here, so 8 and 12, so I2 is nothing but, I can write it as or V2 equal to, let me write it as V2 equal to I2 times Z total. So the Z total is Z total of the circuit from port 2 point of view, 12 plus 8, which is parallel with 4 ohm. Okay, so this value is 20 parallel with 4, which is 20 times 4 divided by 24, 80 divided by 24. I believe this value is 3.33 ohm. So Z22 is nothing but, which is Z total, which is 3.33 ohms. Now once I have Z22, it's easy for me to find the current. So all I care for the current in this branch, Ix. So now I'm going to use the current division rule. So I know I2 current is coming here. It's going to divide in two parts. So if I redraw the diagram, here is 4 ohm and then here is 20 ohm. 12 plus 8, 20 ohm. Okay, here is my I2, here is my Ix. So my Ix, in this case, Ix equal to total current multiplied by opposite resistance or impedance over total impedance. So in this case we have only resistors, so I can say resistors. So 4 divided by 24, so Ix equal to I2 times 1 over 6, and V1 equal to 12 times Ix. So if I substitute that value, 12 times 1 over 6 times I2, so 6 12 get cancelled, that's going to be 2I2. So Z12 equal to V1 over I2, so V1 over I2 equal to 2 ohm. Now I found all 4 parameters. The parameters I have: Z11 equal to 8 ohm, 12 equal to 2 ohm, I believe we have 21 is also 2 ohm, and Z22 equal to 3.33 ohm. So if you remember it right, as long as Z12 and Z21 are same, we call that as reciprocal network. If it is a reciprocal network, I can represent this with the T model. So this, I mean, it's not too big compared to the T circuit, but sometimes we may end up with big, I mean, many elements. So we can represent those many elements into these three. This is called T network. So V1, I1, I2, and V2. Okay, so this is going to be Z11 minus 12, Z12, Z22 minus Z12. So this value is 8 minus 2, this is 6 ohm, that's 2 ohm, that's 1.33 ohm. So this is the equivalent T model. As long as, if it is a reciprocal network, as long as Z11 Z12 equal to Z21, that's called reciprocal network. As long as it's reciprocal network, we can say we can draw the T equivalent circuit. Thank you.